Multiplying and dividing rational expressions is exactly like what we did with fractions, like if there were numbers. So now we're seeing our variable pop up, and we'll have this idea of factoring so that we can cancel out expressions. So with the multiplication property, if you have two rational expressions multiplying each other, you multiply the numerators, multiply the denominators. And then what we can do is look for any common factors. Something we can also do that I'll show here, I'll kind of compare and contrast the two ways we can go about this. In this form, you could start looking across numerator to denominator and see if anything could cancel before multiplying. Sometimes that simplifies it so that the multiplication is more easy to carry out. With division, if you have a rational expression being divided by another rational expression, then what we do is we keep the first term the same, so we still have our a over b. What we can do is change it to multiplication as long as we use the reciprocal of the second expression, so flipping the numerator and denominator. I always use the phrase keep, change, flip. Keep the first expression, change to multiplication, flip the second expression. So keep, change, flip when you're dividing. And then once you turn to multiplication, then it's just what we talked about over here, where you multiply the numerators, multiply the denominators, and then look for pieces to cancel out. Now with this, we can look for pieces to cancel at this multiplication stage. We do not want to cancel anything while it's in this division form because the order isn't correct in that stage. We need to change it first, and then we could start canceling things out if there is anything. All right, so let's try this out. So my first step with these will be to factor anything that I can. So I'm kind of looking in 4 spots. I'm looking at the numerators, looking at the denominators. So this is all completely factored. So I don't need to do anything there. What I could do is look and see if there are any pieces that can cancel out at this stage. Just remember, like, ooh, that 3 and 3 looks enticing. However, that addition symbol causes issues. So if it helps, really we have parentheses there grouping that x plus 3 together. Really, we have parentheses there grouping the x minus 5 together. So we can't cancel those 3's out because to cancel anything in there, we need to see that entire x plus 3 in the numerator. So nothing's going to cancel here, so we're just going to multiply across. Now something we're going to do here is we're going to leave our answers in factored form. So we don't need to worry about multiplying everything out. So in the numerator, I'm going to have 5x times 3x. In the denominator, we're going to have x plus 3 times x minus 5. Now in the numerator, we are going to simplify those because it's not necessarily factored form there. It's just unsimplified. So 5 times 3 is 15. X times x is x squared. The denominator, though, that's factored form. So that we're going to leave as an x plus 3 times an x minus 5. Sorry, that noise might have picked up. My dog was making some noise. All right, here we go. Okay, with this one, we have division. So we could go ahead and just change it right now. So keep, change, flip. Keep the first expression, change to multiplication, flip x minus 4 over 5x plus 1. Then I would look to see if anything can factor, which there isn't anything to factor. Then my next step might be to go through and see where I have addition, subtraction, and just throw in some parentheses so that the grouping is really clear for me. All right, so now what we could see is we have an x minus 4 in the denominator and x minus 4 in the numerator. So at this stage, we could cancel here. So this is where I'll kind of show you 2 ways you can go about it. It's the same as when you simplify fractions. You can either simplify in the process or simplify in the end. So I typically simplify in the middle of the process, but either way is fine. The idea being that I see those x minus 4 values can cancel out, so then my next step would be 5x squared over 5x plus 1. And then at that stage, I'd look for anything to cancel, but again, that 5x plus 1 is stuck with that addition between them, so we can't cancel anything out. The other way is if we just carried out the multiplication, so 5x squared times x minus 4 over x minus 4 times 5x plus 1. And then there we can see the x minus 4 values will cancel. So we'll have the 5x squared over 5x plus 1. So the only difference really is this extra step of actually combining it all together, but you'd see the same pieces that would cancel out and they end up at the solution. So not a huge extra step, but it may be helpful for some of you to write that out rather than canceling in the middle of your work. All right, our next one here. So we have multiplication. So I'm going to leave it in this form here, but I am going to go looking for things I can factor. So x squared minus 81 is our difference of squares. So that can be written as x plus 9 times x minus 9. And then over in the denominator of x plus 4, which I'm going to go ahead and put in parentheses, times. Now you see I have a common factor of 3 in the numerator there. Also, when x has a numerical coefficient that's negative, it's good to take out a negative common factor. So what I'm going to do is factor out negative 3 from the numerator there, which would leave us with a positive x and a positive 4. All over x plus 9, which I'll put in parentheses. So again, you can multiply it all out at this stage, or you can look for pieces that will cancel. It just has to go numerator to denominator. So I can see those x plus 4 values will cancel with each other. I can see those x plus 9 values will cancel with each other. So with that, I'm going to have this x minus 9 left over. I'm going to have this negative 3 left over, and I don't have anything in the denominator. Really, that denominator turns into a 1, but when we divide by 1, we don't need to write that out. So this is going to be negative 3 times x minus 9, and then I could just simplify by multiplying it out of negative 3x plus 27. However, this would technically be the factored form that we were at before there. So we could have stopped there. All right, our last one here has lots of factoring for us to do. But first, before I factor, you could do this in one big step too. You can factor and take care of the keep, change, flip. Let's do it all together. So we're going to keep our first expression like that. I'm going to factor the numerator. So I need values that multiply to negative 20, add up to negative 1. So that's going to be a 5 and 4 with a negative 5 and positive 4. So those two numbers multiply to negative 20 and add up to negative 1. Y squared minus 4 is our difference of squares using a 2 squared. So that would be the same thing as y plus 2 times y minus 2. And again, if it helps, like I said in the simplifying video, if you need to do these off to the side as side work and then come back, that works great too. Just show your work somewhere if you need to show some steps. So you could do it in the process of it, or if you want to do it separately and then bring it all together, that works great too. Okay, so there's the keep part. I'm going to change to multiplication, and then we're going to flip. So this y squared minus 2y is going to be my numerator now. That has a common factor of y, and then that would leave me with y minus 2. And then my denominator is now going to be the y squared plus 7y plus 12. So with this, I need two numbers that will multiply to positive 12 and add up to 7. So that's going to be my 3 and 4. Okay, so now we could go looking for things to cancel out. We have these y minus 2 values. We have y plus 4. And that's going to be it. So this y minus 5 is stuck in the numerator. We also have a factor of y in the numerator. Y plus 2 in the denominator, along with y plus 3. So in the numerator, y times y minus 5 over y plus 2 times y plus 3. And since we're leaving this in factored form, it would stay just like that.